Good morning and welcome to the video for Friday, May the 8th for 5th grade. This is going to cover our lesson working with using unit cubes to find the volume of solid figures. So when we are working with unit cubes, we are going to have something that has a length, a width, and a height that are all equal. They're all one unit. And so if we were to look at a cube, I would have a top, a bottom, and then four sides going around. And so I'm going to have six total faces. I'm going to have six faces that are all congruent. They are all the same length or measurement. And we also have 12 edges going around that cube. And so the length of all 12 edges are equal as well. So I want you to think about if we could put two of these side by side, how many faces we would have total for the rectangular prism, how many edges we would have, and then as we look at part B and part C, I have a demonstration that I'll cut to in just a few moments. But if you have eight regular six-sided dice from board games, you can go ahead and try different combinations. So my Risen Christ students in 3rd grade, I would give you three of the fuzzy dice, and I would tell you to give me three numbers that you could multiply together to get the answer 8. And so that's kind of what we're working with. Think about the number combinations that you can use, and that will inform the way that we can set up the cubes to make our rectangular prism. So go ahead and pause the video if you need to, and then I'm going to cut to my demonstration and we'll answer the questions after that. All right, so let's take a look at the different ways that we could organize our blocks to be able to make a rectangular prism. So we could start by doing things that we would do when we were working with areas. So we could make a 2x4 rectangle and say that it's one block high. We could also take that and tip it on its side so that we have 2 blocks side by side, and then we go 4 blocks high. We could have 8 in a row, or we could tip it on its side. And then the last option that we could do would be to take 4 blocks, make them into a square, and then stack them on top of each other. So we would have a 2 by 2 by 2 rectangular prism for that. All right, welcome back from the break. Let's go ahead and take a look at our answers for our investigate problem. So for part A, if we take this shape that I drew up here, I would be connecting both of these parts together to form a new shape. And so we're going to retain the number of faces and edges in that shape. If we change the shape from being a rectangular prism to something else, then we would end up with a different number of faces or edges. And so as we go into part B and part C, you saw different ways that we could do that. I can rotate the shapes and put them in different orientations, but we are only going to have 3 different number combinations that we can use to get to a volume of 8. So 4 times 2 times 1, 8 times 1 times 1, and 2 times 2 times 2 are my 3 number combinations. And I could rearrange these in different ways, but I'm still going to have the same number combinations. So I have 3 different ways that I could do it, even though I could rotate the shapes to make it look different. So let's talk about our conclusions from this. I don't normally do this part, but I want to explain it. So explain why a rectangular prism composed of 2 unit cubes has 6 faces. So how do its dimensions compare to a unit cube? It stays the same. So if I take 2 of these and put them side by side, or 3 of them and put them side by side, as long as I'm keeping a rectangular prism, I'm still going to have one longer face on top, a longer face on the bottom, and then I'm going to have 2 shorter faces on the far end, and then everything else will be the same size. And so as we extend that out, we are not going to retain the exact same dimensions as a unit cube, and that's why we have the different number combinations. So for number 2, explain how the edges compare. The number of edges are going to stay exactly the same. We are not adding extra edges just because we put an extra cube on the end. And then the last one, describe what all of the rectangular prisms we made in step B have in common. So for step B, again, we were looking at these. They are all going to use the same number of blocks. So that would be the one thing that they would have in common, they are going to have different measurements, so different lengths or widths or height, depending on how we arrange those blocks. So let's go ahead and I'm going to skip over that bottom part. Let's go over to our share and show now. So a rectangular prism shown here is going to be made up of 1, 2, 3 unit cubes. So for this one, number 2, we are going to end up with 3 times 4, and we don't have this extra width coming out like we have in number 3. So I'll kind of show you how that works in just a moment. So we're going to just have 12 unit cubes for this one. And so right now I have 3 times 2 for this one face, but I'm going to have 2 sections of that. So I would end up with 3 times 2 times 2, or you could do 2 times 2 times 3 to get the same thing. And so that is going to also give us 12 unit cubes. It's just going to look a little bit different. And then for this last one, we don't have a normal shape. So we can just count the unit cubes. We don't have to worry about extra dimensions right now, where we have this one kind of coming towards us as well. So we just have 1, 2, 3, 4, 5, 6, 7 unit cubes for that. So for number 5, how are the rectangular prisms in these two related? Well, they use the exact same number of cubes. So can you show a different rectangular prism with the same relationship? Yeah, we could. So one of the ways that we could do that is to go ahead and make a rectangular prism that ends up using 12 cubes and could be 2 by 6 instead of 2 by 2 by 3. Or we could even make one that's just 12 cubes in a straight line. And so with that, we have a similar relationship because we are using the same number of cubes, even though the shape would look different. For problem solving, I'll take a look at number 6 and number 7 real quick. So number 6, we have 5 unit cubes here, we have 5 unit cubes here. So even though they look a little bit different, we are going to be equal for that. Actually, I'm going to uncircle that real quick. And then for number 7, we have 4 on this side. We have 5 on this side, and so that would be less than. So looking at the homework problems real quick to finish out our video, for Risen Christ students, I'm going to ask you to do the even numbers, including number 10. So if you use this, all you need to do is show a picture. So you could draw it and go ahead and make like a 4 by 4 by 1. Think about your number combinations that you can use. I'm going to ask you in the Google form which number combinations will work. So that will save you having to try to draw into a document. But for the purposes of doing that on the page, I want you to try to do that before you put in the answers. So 2 through 10 for even, and then 1 and 2 on the back. I don't think there's anything that I need to discuss with this. Oh, I want you to take a look at number 5. So the opposite sides of a parallelogram. So think about what we have done over the last few lessons with our shapes and see if they are always going to be congruent to each other or if there might be something different. So number 5 would be the other one that I would ask you to take a look at. So those are the things I want to talk about for today for the lesson. If you have any questions, please feel free to ask in Google Classroom. I hope the demonstration was helpful for you. It took a little bit of time to set up because I don't use that program very much, but it's kind of fun. I might include a bonus thing of me flipping the table for entertainment value at some point if I end up using that again. So hope you have a great day. The homework video for this will come out at 6 p.m. So stay tuned for that. I'll see you in the next video, or I'll see you on Monday.